Alright, how you guys doing there? Grade 10s. Taking a look here, and we're going to check out factoring using the greatest common factor. Alright, great. That's what GCF stands for. Alright, so I don't know if you recall, but back in grade 9, should have learned something called this distributive property. Okay, and basically what that means, you'd have to, if you had something like 3 times g plus 2, what you're doing is you distribute that 3 to both terms inside the binomial. So that would give you 3g plus 6. Okay, so basically now we've got to flip our thinking, which is great because we're flipping our classroom. So if you were given this to start with, what you'd end up doing is you would try to find factors. So 3 and g, those are the factors there. But now if you look at the 6, we can break it down just like we did in an earlier part of this unit into 2 times 3, right? So we got the prime factors. So now we're going to take a look at, in this, right, what would be the greatest common factor? Well, we got a 3 here and a 3 here. No g's there, no g's there. So that's all we can do. So remember what we did over here? Well, it's the same thing we're going to do here. You pull the 3 out, and then you have what's left over is a g. You pull the 3 out, so that, right, because it's the greatest common factors, and you're left with the 2. So when you're factoring that, that would be your answer, right? So let's take a look at another example. All right, so say for example you had something like 8d plus 12d squared. Okay, that's all good. Now we can take this and break this down. Let's see, the factors of 8 are 2 and 2. That gives me 4 times 2 times d. And then if we look at this guy here, we would have 2 times 2 times 3 times d times d. Okay, see how I broke that down? 12 can be factored down to 2, 2, and 3. And d squared is the same thing as d times d. Alright, now I'm showing you this as you move on. If you start to see a greatest common factor right out without breaking it down like that, you can go ahead and do that. I'm just trying to show you guys what's going on here. So I got 1, 2 here and 1, 2 there. That's good. I have 1, 2 here and another 2 here. So I've been able to get those guys grouped. So what's 2 times 2? Well, that's 4. So I can definitely pull out a 4 from that when I'm factoring it. Okay, and I know it's going to be a binomial, so I'll put my brackets, and I know there's going to be a plus sign separating them, so I'll pull that already. So here for sure there's going to be a 2, right? That breaks down, and here that's going to be a 3. 4 times 2 is 8, and 4 times 3 is 12. Okay, that makes sense. Looks like we're doing pretty good. Now here we have 1d, and here we have 1d, so I can also pull out a d. But you see this guy here is left over, so I put a d. So what happens there is I have factored that successfully. Again, to check if I'm right, I would just use the distributive property that you learned before. 4 times 2 is 8, times d is 8d. 4 times 3 is 12. d times d is d squared. As you can see, it goes in there. Alright guys, I'll give you one more example and then I think you guys will be good to go. Right. So, if we take a look at this one, we'll put in something that's a little bit harder. We got minus 20 c to the 4th power d to the 5th power minus 30 c cubed d squared. Alright, minus 25d squared. Alright, again, excuse my penmanship, should have been a doctor. Anyways, so when we look here, you see we have a negative, and a negative. So I'm going to pull that out right off the bat. Now, like I was explaining earlier, if you could see something right away, I can see all that. 5 would definitely go into all those, right? So I'm going to pull out the 5. Right, so if you start to see that as you go, if you can't, you'd have to factor that all out, which is fine. So I know that this would be a 4, because 5 times 4 is 20. I know in my next one, again, because that's a negative, and I pulled out a negative, this is going to have to be positive. And I know that 6, right, negative 5 times positive 6 gives me negative 30. And then over here, I know that this is going to have to be positive 5. Negative 5 times positive 5 gives you negative 25. So I got all that set up. Now I have to look at the variables. C to the fourth, C to the third, and there's no C's. All right. Now because there's no C's.
Samantha, sorry. Please go to the library to see Miss Gagnon.
All right. There's a technical difficulty. Right. We'll keep going here, but also note one thing I forgot. There is actually a C here in the original question I had. So you can see there's 4 C's there, 3 C's there, and 1 C there. So I can actually bring out. I should have left a little bit more room, so I'm just going to erase this. Right. I'm going to put a 5, and I can bring out a C. Right. So I'd be left with 3 C's here. I'd be left with 2 C's here. And remember, that's just a C there. If I bring it out, that's just like, C to the 0 power, which is 1. So I don't have to put anything in there. All right. Let's take a look at, here's 5 D's, 2 D's, and 2 D's. All right. So when I do that, because I know that that's 5D times D times D times D times D 5 times, then that's D times D, and that's D times D. I can bring out D squared. So here, remember your law of exponents. Hopefully you remember that from grade 9 as well. So that would leave me with D cubed. Again, there'd be nothing here because that's D squared. So we leave that one. And this guy here would have nothing as well. So there, I have totally factored that. Again, to check. 5 times 4 is minus 20. C times C cubed is C to the 4th. D times D squared times D cubed is D to the 5th. Minus 5 times 6 is negative 30. C times C squared is C cubed. D squared would stay there, it's the same. And then on this one, negative 5 times 5 is negative. Get rid of that. Would be negative 25. And then CD times that would just stay CD squared. Okay, so that would work out. Hopefully that makes sense, and thank you for watching.